Hello. In this video, we're going to look at taking some derivatives that involve exponentials along with products and quotients. So our first example, we have the function y equals e to the 7x times the quantity x cubed plus 5x squared minus 6. We want to take the derivative of this function. That is a product, so we are going to use the product rule. Our first times the derivative of the second, the derivative of x cubed plus 5x squared minus 6 is 3x squared plus 10x plus the second times the derivative of the first. And the derivative of e to the 7x is e to the 7x times the derivative of that exponent, which is 7. Now we could go ahead and distribute everything, expand, combine like terms, but one thing we're going to notice is every term is going to have an e to the 7x. So let's go ahead and factor that out front. So if we factor e to the 7x out of this function, we're going to be left with 3x squared plus 10x for our first piece. And then we're going to have this set of parentheses times the 7 here on the end. I'm going to go ahead and distribute that 7. So we'll get 7x cubed plus 35x squared minus 42. And then just combining like terms and writing that polynomial in standard form, we get 7x cubed plus 38x squared plus 10x minus 42. And that would be our derivative. All right, our next example here is a quotient. We've got negative 8 e to the 2x over 6x plus 9. So when we take the derivative of this, we are going to use the quotient rule. Bottom times the derivative of the top. The derivative of negative 8 e to the 2x is negative 8 e to the 2x times the derivative of that exponent, which is 2, minus the top times the derivative of the bottom, 6x plus 9, that derivative is 6, all over the bottom squared. Now don't be tempted to divide out your 6x plus 9s because we don't have a 6x plus 9 factor in our second piece. All right, so let's go ahead and clean this up just a little bit. Let's see, we're going to get 6x plus 9 inside the derivative of our top here. That's going to simplify to negative 16 e to the 2x. And then our second piece here, we're going to get minus a negative 8 times 6, so that'll be plus 48 times e to the 2x. And then we can distribute our 16 negative 16 e to the 2x. So 6x times negative 16 e to the 2x is going to be negative 96x e to the 2x. And then 9 times that negative 16 e to the 2x is going to be negative 144 e to the 2x. We still have our 48 e to the 2x at the end, and it's still all over 6x plus 9 quantity squared. All right, if we combine like terms in the numerator there, we're going to get negative 96x e to the 2x, and then negative 144 plus 48 is going to give us also negative 96 e to the 2x, all over 6x plus 9 quantity squared. Take this up here. All right, so if we factor out our GCF in the numerator, we get negative 96 and an e to the 2x. And if we factor that out, we're left with x plus 1. In the denominator, we also have a greatest common factor. 6x plus 9 is has a GCF of 3, so if we factor that out, we have 2x plus 3. Now we want to make sure and square this whole thing, so make sure you put parentheses around the whole thing. And we can go ahead and square that 3 out front, and then just leave the 2x plus 3 quantity squared. And then our last step here is to simplify. 96 divided by 9 is 32 over 3. So we're going to get negative 32 e to the 2x times x plus 1 over 3 times 2x plus 3 quantity squared. So that one wasn't involved algebra. The only thing that we did as far as calculus was finding these two derivatives here. Other than that, it was all algebra. All right, let's do one more that is also a quotient. Here we have e to the 2x minus e to the negative 2x all over x squared. Now this one we could actually do as a quotient or as a product. If we wanted to, we could rewrite e to the 2x minus e to the negative 2x in parentheses multiplied by x to the negative 2. So we could do this one either as a product or as a quotient. I like to avoid the quotient rule as much as I can just because I can never remember which one comes first and it makes a difference. With the product rule, it doesn't. So let's go ahead and take the derivative using the product rule and this rewritten form. So we're going to get the first just as it stands times the derivative of the second. The derivative of x to the negative 2 is negative 2x to the negative 3 plus the second times the derivative of the first. The derivative of e to the 2x is going to be 2e to the 2x, because remember we need to multiply by the derivative of that exponent, and then minus the derivative of e to the negative 2x is going to be a negative 2, so minus a negative is going to give us plus 2e to the negative 2x. Alright, and go ahead and clean this up. That'll be e to the 2x minus e to the negative 2x all over 2, sorry, that 2 is not going to go on the bottom. This is going to be a negative 2 multiplied out by that exponential piece. And we'll have an x cubed in the denominator. And then the second piece is going to be 2e to the 2x plus 2e to the negative 2x all over x squared. And if we wanted to, technically we're done here, but if we wanted to, we could go ahead and get a common denominator of x cubed. That means we need to multiply by x in the denominator, and we need to multiply by x on each term in the numerator. And so we'll get, I'm going to go ahead and distribute this negative 2. So we'll get negative 2e to the 2x plus 2e to the negative 2x plus 2x e to the 2x plus 2x e to the negative 2x. Remember, we cannot combine like terms unless they have the same terms, and that means the same number of x's on the base and the same exponent, all over x cubed. So here we have a GCF of 2 if you wanted to factor that out, but it's not going to really benefit a whole lot. I'm actually going to just say that that is your answer. You could do some factoring. You could factor an e to the 2x out of these pieces. You could factor an e to the negative 2 out of those pieces, but it's not going to really help you a whole lot. And so I'm just going to stick with